All right, AP Environmental. Today we are going to cover Unit 4, Topic 4.2, which deals with the formation of soil. This may not sound too exhilarating, but it actually is kind of interesting in how soil forms and why it's so important to living things on our planet. So, kind of a big topic. So, again, kind of pay attention to this. Again, if you want to, kind of watch the first half of the video, take a break, then watch the second half of the video. That's probably a good idea instead of watching the whole thing straight through. But whatever you want to do is fine with me. Okay, so soil formation is, again, kind of one of these big geological processes, right? We talked in the last video about plate tectonics. All the plates of the Earth move around because of the convection currents underneath the surface and all that type of stuff. But soil formation, strictly is happening at the surface of our planet. So let's first talk about what soil is. Soil is kind of two things. It's sort of an organic component, or there's an organic component to it, kind of a carbon-based component. And then there's an inorganic component to it, kind of a non-carbon-based component. So, these are just two things that make up the soil. But I think what's more important is what soil does. Like, what does it actually provide? One thing that soil does is, and this is a really important thing, is it filters water or purifies water. So soil is kind of a natural filtration system for water. If water is trapped, I don't care if it's moving through the surface, through soil, or if it's moving downwards through soil, the soil will actually filter and purify that water. So that's a really important thing. Number two, I think this is kind of an obvious one. It's an area for plant growth. So plants grow in the soil. They utilize nutrients from the soil. It's a home for animals to live, like little earthworms here. They live in the soil, so that's important to them. It's also a recycling area for decomposers, right? Decomposers live in the soil, little bacteria, things like that. And that's kind of their medium for survival, and they do what they have to do. So all of these things are again, we've talked about this term before, ecosystem services, right? These are things that soil provides. So if we don't have soil, or if soil is removed, and we're going to talk a lot about some things today that remove soil, that means the soil can't do these things, right? So it's really important that we take care of our soil. We kind of make sure that nothing happens to it, because if something happens to it, then it doesn't provide these ecosystem services. All right, so there they are again, ecosystem services for soil. All right, now the formation of soil is actually pretty simple. Before we get into both of these things, there's two processes. One of the things I think is kind of important is that we understand that there's a time factor involved. Soil doesn't form overnight. It takes hundreds, maybe even thousands of years for soils to form. So the reason why that is basically because of the two things. Where am I going to put myself? Let's put myself right in the middle here. The reason why soil takes so long to form is mainly because of the two processes that are involved, right? There's one process that's kind of inorganic, which is basically just the breakdown of rock, right? There's an inorganic component to soil, which is basically what rock is. But that rock has to be broken down and weathered. That's breaking down of rock into little tiny particles, and that takes a lot of time, right? This doesn't happen overnight. Now, the other process is the organic material, the carbon-based material, has to accumulate in the soil. And again, this doesn't happen overnight. It takes a long time. So If you've got a very mature soil, first of all, that soil is probably very old, and it's going to have a lot of organic material in it. It's going to have a lot of inorganic material as well, but it's going to be a nice mixture of both of those things. And again, it takes a long time for those things to form. There's three vocab words here that I kind of want to get into before we move on. They're terms that you've probably heard of before, but I want to make sure that we kind of understand the difference between the three. The terms are weathering, erosion, and deposition. WED, wed. All three of these things have something in common. They're all kind of part of the same process. But weathering is simply just the breakdown of rock. So think about all some things that might contribute to the breaking down of rock. Things like water accumulation, ice, wind, even plants and animals can actually break down rock. All right, so the weathering of rock is just the breakdown into smaller pieces. Erosion, because a lot of people think erosion and weathering are the same thing. They're not. Weathering is the breakdown. Erosion is the actual movement of those particles. So once they get broken down into smaller pieces, then they can get moved from one place to the other. They can be carried by the water or wind or even gravity, I suppose, can move some of these particles. But erosion is the movement. And then deposition is where those particles end up, where they accumulate. So, for example, like a sand dune in this picture here, a sand dune is the result of rock that is broken down, it has moved, and it's accumulated in this one area. You got this big dune of little tiny particles of rock. It's what sand basically is. So make sure we understand again the differences between those three terms. You're going to hear me pretty much the rest of the year talking about these terms in one way or another. But again, make sure we can distinguish between those three things. Okay. Now, the properties of soil are affected by 5 different things. I'm just going to run through each one of these kind of individually here, but there's 5 factors that affect soil. One of them is the rock. The rock is what we call the parent material. Um, there's lots of different types of rocks, right? You got like igneous rock and metamorphic rock and sedimentary rock, and even amongst those, you've got like different types of rock. We're not going to get into all that type of stuff, but because there are different types of rock, you can get different types of soils from that rock. Like that hopefully makes sense to you. Another thing that affects soil is climate. Whether or not it's a cold climate, is it a warm climate, is there a lot of precipitation, is there not? Colder climates tend to have poor soils. And the reason why they're poor is because there's not a lot of organic matter in a cold climate. I think about like the tundra and up in the Arctic and places like that. The soil there is not really that nutrient rich. There's not a lot of organic matter in it. There's not a lot of water that flows because it's frozen. So that means that there won't be a lot of rock that weathers to produce that soil. So typically colder climates have poor soils. Now warmer climates tend to have more nutrient rich soils, depending if there's a lot of organic life there. Um, they have high rates of decomposition. You get a lot of nutrients that get into the soils. So they're kind of just the opposite of one another. Another factor that affects the soil is topography. It's kind of the lay of the land. If it's like a really flat area of land, that soil might be a little bit different than if there's a lot of rolling hills and things like that, because the slope of the land may affect erosion, and even weathering. That has an effect on soils. The organisms that live in the soil or that live near the soil, even on top of the soil. Plants, for example, plants not only take nutrients from the soil, but they also put chemicals into the soil that can actually speed up weathering of the soil and things like that. Some animals burrow in the soil, like make little holes and things like that, like earthworms. Some animals compact the soil by stepping on top of it, like larger animals, things like that. And the final factor really is just time. I talked about this earlier. The older the soil, the more time it has to accumulate, organic material and things like that. So time is a big factor that affects soil as well. So again, these are the 5 factors that influence and impact the types of soil that we have. All right. Now, one thing that I think is important that you understand is not all soil is the same. I mean, just looking at these 2 pictures here, this is showing us 2 different soil types. Even if you, let's say, for example, went down south, let's say down to like Georgia or South Carolina or something, and you just kind of went on a walk and I don't know, say you had a shovel and you just dug up some soil. And then you did the same thing like here in Northwest Indiana, okay, and just kind of looked at the soil, you would probably see some differences. There might be a color difference, there might be a texture difference to it. So not all soils are the same. I mean, some soils are really good for growing crops. Some soils are good for building I don't know, a house in it or something. I mean, not every soil has the same properties and the same qualities. Now, to understand the different soil types, we kind of need to understand 2 things. We're going to talk about one of them today, the other one in the next video, and we'll do that one more either tomorrow or next week. But we need to understand something called soil horizons and soil properties. Soil horizons are distinct layers of soil that kind of appear as you get further and further down. Okay, so if you were, for example, going to build or dig, let's say maybe a 10 or 15-foot hole in the ground, you would start to see these different horizons, and most of the time there's a color difference between them, and there's also usually a texture difference too. But we'll kind of get into that. But these are what we call soil horizons. The entire thing is what we call a soil profile. So here, for example, is a soil profile. Let's say we just have the ability to kind of reach down and just kind of pull up this giant chunk of soil and then just kind of examine it. And what you're going to see again is these distinct layers. These are called horizons. So what we're going to do is we're going to kind of break down each horizon and kind of get an understanding of what each one is all about. Okay. All right, the first horizon, we're going to start from the top and move our way down. So we're going to start with what we call the O horizon. The O horizon is also known as the organic layer. That's why we call it O, I guess. I don't know. At least I think that's what we call that. But anyway, that upper layer, it's only a couple inches, maybe 2 inches, 3 maybe at most. This is the layer that we walk on top of. It's the layer that we come in contact with. It's mainly organic matter. I mean, think about what's in that organic layer, right? You got like grass and dead leaves and twigs and maybe like dead animal carcasses. I mean, all that stuff is in that O layer. It is highly organic, lots of life in that layer. Okay. In forest soils, it is extremely common, right? All because of all the organic matter in a forest. Some soils, like for example, in a desert, you may not even have an O horizon, because maybe there's no organic matter there. That possibly could be. But in this particular profile, you definitely have one. Now, the next layer down is called the A horizon. It's also known as topsoil. You've probably heard of topsoil. Now you can go to like Home Depot and you can like buy bags of topsoil. Topsoil is below the O horizon. And again, it's usually about 10 inches or so below. I mean, again, it kind of varies. Don't necessarily think that these numbers are definite things. They're not. But the A horizon, since it's below the O, it's mostly organic matter, but there's also some inorganic material mixed with it. So it's a nice little mixture of both organic and inorganic. It's probably a little bit more organic than inorganic because it's so close to that O horizon, but that's what we call the topsoil. Now, below that, we have what we call the B horizon. The B horizon is what we call the subsoil. Now, the subsoil is mainly inorganic. It's almost like the flip side of the A horizon, where the A horizon is mostly organic and a little bit inorganic. The B horizon is mainly minerals, which are inorganic, and there's a little bit of organic matter. So it's kind of like the flip side of the A horizon. And then we get down to the C horizon. The C horizon is basically rock. This is the parent material. It's probably not weathered very much. It's probably very solid. So like if you were digging a hole, like you just keep digging, you dug through the O, you dug through the A, you dug through the B, you would probably know when you reach the C horizon because it's extremely tough, hard to get through that because it's again basically rock. So again, this is your soil profile. Now, most of the time, when you see a picture of a soil profile, it's going to have those four distinct layers. You just have to know which layer is which. Just remember, O comes first, and then it's just A, B, C. All right, but then you need to know like some details about each one of those layers as well. Now, sometimes you're going to see soil profiles that have 5 layers. All right, so this is the most common one that you're going to see, but I'm thinking about the AP exam. You may see a picture that has 5, and I want to make sure you understand why some soil profiles have 5 because they don't all. Okay, so if you're looking at a picture like this, for example, let's kind of just review our profiles or our horizons. You've got your O and your A. Okay. By the way, this word humus. All right, humus is basically just the organic stuff at the top. Okay. Don't conf- don't confuse the word humus with hummus. Hummus is that like bean crap you put on crackers and stuff and eat it. That's different. Okay, so humus is an organic layer of soil. Hummus is the stuff you eat. They're two different things. Anyway, um, so again, you got your O and your A. Okay, the top 2 layers of soil are always going to be these two, right? Your O and then your topsoil horizon right below. Your bottom 2 are always going to be your B and C, right? Your C layer at the bottom, that's your rock, that's your parent material. The B horizon, that's your inorganic, that's your subsoil, this zone of alluviation. We'll talk about that in a minute. But the bottom 2 are always the B and C. So always remember upper 2 are O and A, bottom 2 are B and C, and then we have this layer in the middle. Like, what is this? All right, now this layer is kind of distinct. It's called the E horizon. It's also known as something called the zone of eluviation. So, vocab time. Now, the reason why you have this layer is because some soils, in fact, a lot of soils, to be honest with you, a lot of soils have things in the upper layers that can move through the soil. A really good example is iron. like iron ions, like Fe+2, Fe+3. There's different ones, but iron is a metal, right? And a lot of times the upper layers of the soil will have metals in them, things like copper and iron and whatever, right? Calcium or something. But those metals, anytime it rains, those metals can move. They can be carried by the water. That's called leaching. And when those metals leach, they move their way through this zone of eluviation and they accumulate in the B horizon. In fact, you see in this picture here how this B horizon is kind of a reddish brown color. That is very distinctive of iron. When iron comes in contact with water, there's oxygen in water, it forms rust, like it forms iron oxide, and rust is kind of that reddish brown color. So what you're seeing in this soil here is most likely a lot of iron oxide, which has been accumulated because those iron ions have been carried or leached through these layers, especially the E horizon, and they've accumulated here. Okay. So, like, if you have a profile that only has 4 layers, there probably isn't any eluviation happening. There probably isn't any of that leaching happening. But if there is 5 layers, then there is. So you kind of have to distinguish between the two. All right, so 2 terms here to kind of know. All right, the first term is eluviation. It's also known as leaching. That's where those materials like iron just move their way through the soil. And that E layer is basically the region that they're moving through. And then the term illuviation is the accumulation of those materials. So the B layer, which is where all those metals will accumulate, because they're not going to go past the rock layer, they can't get through there, but they're going to accumulate on top of that rock in that B layer. And usually you get a very distinctive color, usually. Okay. So again, make sure we know the difference, 2 vocab terms, but kind of important that we know those. All right. I want to go back to this term here, erosion. We talked about the breakdown of rock. That's what erosion is. And lots of things can cause, rock to break down. But what I want to focus on for the rest of the notes today is number 4 here. All right, human related factors. This class is a lot about human impact, right? So let's talk about some things that humans do to kind of cause the erosion of rock, kind of force rock to move from one area to the next. All right, so the first one is kind of an obvious one, I think. It's deforestation. Humans remove trees, and remember, roots hold soil in place, especially those top layers like the O and the A horizon. So when we remove trees, the soil is very loose and it can easily erode and move somewhere else. All right, so that's a human impact. Another one is animals. Even though these are animals, humans depend on a lot of these grazing animals for food. So we raise a lot of these animals, especially in the United States. There's tons of cattle ranches and things like that in the US. But these animals, when they graze on the land, right, they're removing that upper layer of soil. So if that upper layer is removed, now it makes the next layer, like the A layer, it makes that layer much more erodible. All right. So, overgrazing of animals, that does impact soil and it affects erosion. Pesticides and fertilizers, these are chemicals. When we add them to crops or plants or whatever, and when those things get into the soil, a lot of times they end up killing the organisms in the soil. And if you kill the organisms that live in the soil, that lessens the quality of the soil. and that could create a more erodible soil. The last one, we're going to talk about this one a lot more in Unit 5 when we have our unit on agriculture. This is called soil tilling. Tilling is basically just turning the soil upside down. And when you do that, it really impacts that organic layer of soil. Again, it makes the soil much more erodible. All this dust just kicks up in the air and can easily be transported by the wind to other areas. So, again, tilling soil, even though it may be a necessary practice if we're going to grow food, it is something that erodes soil and makes the soil quality much less. All right, so make sure we know those impacts. All right, the final thing here today is some of the dangers of erosion. What's some of the impacts of soil moving from one area to another? One of the biggest impacts that erosion has is on water. It says here soil particles moved during erosion are often washed and blown into waterways, things like rivers and streams and lakes. So, I mean, think about if you have a nice, clean, clear river or a lake or whatever, and all of a sudden you add a bunch of dirt to it, a bunch of soil, that's going to decrease water clarity. It's going to make the water, much less clear. So that means much less light there's going to be for plants to photosynthesize. So that's a problem. A lot of sediments, dirt, soil that gets into water can actually get into the gills of fish and clog them up and actually suffocate the fish. That's not a very good thing. And finally, a lot of soil, that erodes, a lot of that soil has nutrients in it, right? So if those nutrients get into the water, well, we've talked about this before, right? Eutrophication, right? And that could create a whole bunch of issues, right? Algae blooms and all that type of stuff. So there is some issues with this erosion of our soil. We don't want our soil to erode away and make its way into water, because then it's going to decrease our water, uh, our water that we have, and we only have so much fresh water on this planet. So make sure we know some of those. All right, guys, that was a lot for today. So hopefully you kind of watch this video, maybe pause it, and then watch the second half. But there will be a lot of questions on next week's quiz. I will give you an update on that soon from these notes today. So have a good day. I will see you hopefully soon.